Alright, here we go. We're continuing section 4 of chapter 4, and we've been looking at finding the trig functions of any kind of an angle using the definition of based off of actually a combination of the unit circle and the right triangle, where we extend the right triangle and use the idea of similar triangles to be able to write the ratios of the x values, the y values, and the r values, or the what we would call the radius there, the hypotenuse of a right triangle. So we're going to do an example here where we have point P at -5, -7 be a point on the terminal side of an angle theta. So here's my angle theta in standard position right here. This is theta, and as you can see, this is a third quadrant angle because my terminal side is in the third quadrant and intersects this circle that I've drawn at the point -5, -7. Now I didn't really need the circle, but it's kind of nice to see that when I set up the values here, we are to find the values of the 6 trig functions. So if I was to, and I'll try to do my best here and freehanded, if I was to draw a right triangle here, this distance would be 5. This distance here would be, the y value would be 7. The distance would be 7. This is actually -5 because I'm going to the left, and 7 down, -7. And I could find the radius here of my circle, or the hypotenuse of this right triangle, using the Pythagorean theorem. If I call this r, I have r is equal to 5 squared plus 7 squared. So this r squared is, so this is r squared is equal to 25 plus 49, which should be 74. So that means r is the square root of 74. Now I have all that I need, along with the definition in the last video, to find the sine, cosine, and so on. The sine of theta, the cosine of theta, the tangent of theta. Now typically, if you have these three, the other three are just the reciprocals. So I'll go ahead and write the sine of theta, which would be the y value. Now the y value here is -7 over r. So it's the y value over r, which would be -7 all over the square root of 74. If I rationalize my denominator by multiplying top and bottom by the square root of 74, I will get -7 square roots of 74 all over 74. It does not simplify. The cosine would be the x value over the r value. So that would be, the x is a -5, so this is -5 all over the square root of 74. R is going to be a positive number here in these problems. So the sine, the SIGN sine of your trig functions is going to be based on the x and the y, and of course what quadrant you're in. Don't forget, all students take calculus to remember when your different trig functions are positive and when they're negative, based on the quadrant. So I'm going to rationalize this one as well by multiplying top and bottom by the square root of 74, and I get -5 square roots of 74 all over 74. Now, unless they ask for you to write it out as a decimal, just leave it in a simplified radical form here. The tangent of theta would be the y over the x. So the y value is a -7. The x value is a -5. It would be -7 over -5, which would be, it's smeared, still smeared, there I got it, which would be a positive 7/5. Now, I'm not going to stop here because they want all 6, but you can see these are the main ones: the sine, the cosine, the tangent, because the other 3 are their reciprocals. The reciprocal of the sine of theta is the cosecant of theta. The cosecant of theta would be r over y, so it would be this over this, which I'm just going to write as negative the square root of 74/7. The secant of theta is the reciprocal of the cosine of theta. So the cosine is x over r. This would be r over x, which would be the square root of 74 over -5, or negative square roots of 74/5. And the tangent of theta, the reciprocal is the cotangent of theta. These are reciprocals, so the tangent is y over x. This would be x over y. It'd be -5 over -7, or positive 5/7. And I have all 6 trig functions. The diagram I draw out at first just to make sure I can keep track of my sines, SIGNS sines, and of course find my r value in this case. Now, let's talk about a really important idea called the reference angle. The reference angle I made mention of for just about a few minutes in a previous video, but the reference angle is the angle, it's an acute angle that when you have theta drawn in standard position, like this example right here, the reference angle for theta is the acute angle, which they call theta prime. A lot of books will use alpha. You know, looks kind of like the fish, like that. But in this book, they use theta prime, formed by the terminal side of theta, that would be in this example that I have drawn here, this terminal side, and the horizontal axis. Well, in this case, in the problem that I have drawn up here, my reference angle would be this angle here from the terminal side to the horizontal axis. It's got to be the acute angle. They would call that theta prime. And there's clearly a relationship here with the reference angle and the different angles that you could have drawn out, whether it's a first quadrant angle, a second quadrant angle, a third quadrant angle, and so on. And I've got them written out here, where in the first quadrant, your reference angle, it would be the angle itself, it would be theta prime, would be whatever that acute angle is. But in the second quadrant, it would be 180 or pi minus that reference angle. In the third quadrant, which I have drawn here, this would be 180 degrees plus the reference angle, or pi plus the reference angle. And in the fourth quadrant, 360 minus the reference angle, or 2 pi minus the reference angle, like that. So you should try to put to memory these relationships here with the reference angles in each of the quadrants. And we'll find the reference angle in these next 4 examples here. I start off with a fairly easy one, 150 degrees. 150 degrees is, first off, I want an angle that's positive, that's between 0 and 360, or between 0 and 2 pi radians. And I have that here at 150. So the relationship 150, by the way, would put me into the second quadrant. It's between 90 and 180. 150 would put me in the second quadrant angle if I drew it in standard position. And in the second quadrant, since this, by the way, is in degrees, I'm going to use the degree model here at the top row. This would be in the second quadrant, would be 180 minus my reference angle would be, in this case, 150. So 180 degrees minus my reference angle would have to be 150 degrees, this angle. So in this case, my reference angle is going to be 30 degrees. Now in this next example, kind of similar looking because it's in degrees, but notice it is a negative angle. Now when I'm finding reference angles, I find it a lot easier if I am working with the idea of a positive angle between 0 and 360, or between 0 and 2 pi. So I'm going to rewrite this by finding a coterminal angle. It's not going to be the same as theta, but it's going to be the same as far as finding the reference angle. So I'm going to add a multiple of 360 on here. I only have to add 360 one time. So negative 157.5 degrees plus 360 degrees would be 202.5 degrees. Now these are 2 different angles, but they are coterminal angles, and because they are coterminal, they have the same terminal side, they're going to have the same reference angle because it's all based on the terminal side. So in this case, I'm in this, the third quadrant. This is between 180 and 270, right? 0, 90, 180, 270. So I am going to use this relationship. I'm going to say that 180 degrees plus my reference angle is going to be equal to the 202.5 degrees. So if I subtract 180 from both sides, I'm going to get 22.5 degrees for my reference angle, for theta prime. And that's how I work the first 2 in degrees. Now I'll work the next 2 in radians. I have 5 radians, not 5 pi, 5 radians. Now remember, a radian is about 57 degrees. So 5 would be probably somewhere between 270 and 300 degrees. So I am definitely within the 0 to 360, but I am looking at this between 0 and 2 pi. And this is 2 pi. Pi is about 3.14, so this would be about 6.28. 5 is clearly in there. Now, if it helps you, remember this is 0 degrees, 0 radians. This is 90 degrees, or pi over 2. Now, pi over 2 would be approximately 1.57. This is 180 degrees, or about pi radians, 3.14. This is 270 degrees, or 3 pi over 2 radians. Now 3 pi over 2 would be 3 times 3.14 divided by 2, and that is about 4.71 approximately. And then all the way around, a full revolution would be 360 degrees or 2 pi, so that would put me at about 6.28. Do you see how 5 is going to be between these two? It's going to be in the fourth quadrant. So in the fourth quadrant, with respect to radians, my relationship is 2 pi minus theta prime. So I'm saying 2 pi minus theta prime is going to equal 5. So that means theta prime is going to be 2 pi minus 5. Now, I could leave it like that. It's a little awkward looking. I could approximate it. This is, as I said before, is about 6.28. So I could say theta prime is approximately 6.28 minus 5, or approximately 1.28 radians. A little weird with the radians. I know you guys are probably feeling more comfortable with degrees, but you got to get used to them. They don't go away. All right, this next guy here, this fourth example, 13 pi over 3. 13 pi over 3 is bigger than 2 pi. I can tell you it's bigger than 2 pi because 13 divided by 3 is 4 1/3. So this is like 4 1/3 pi. 4 1/3 pi is way too big. I want it to be between 0 and 2 pi. So what I'm going to do here is I'm going to start subtracting 2 pi's off of this. If I take 13 pi over 3 and subtract 2 pi, now 2 pi is the same as 2 pi over 1, so this is the same as 13 pi over 3 minus, multiply top and bottom by 3, 6 pi over 3, I would get 7 pi over 3, which is still too big. I take 7 pi over 3, I subtract another 2 pi, which is 6 pi over 3, and I get pi over 3. That guy's okay. Pi over 3 I know is between 0 and 2 pi. In fact, I know pi over 3, because I took the time to memorize that table like I told you guys to, is 60 degrees. This is a first quadrant angle. Well, in the first quadrant, my reference angle is that angle. So for my reference angle here for 13 pi over 3, it's the same as the reference angle for 7 pi over 3. It's the same as the reference angle for pi over 3. It is pi over 3. Now, you got to get a little bit used to it. You're going to be using it. I'm not right there yet, but I'm going to try to show you how I can use the reference angles on these problems to actually evaluate the trig functions. All right, so let's look first here. To evaluate trig functions using the reference angle, determine the function value of the reference angle, which means you have to find the reference angle, and then you're going to make sure that you have the appropriate sign based on the quadrant in which theta lies. That's where you use that all students take calculus. Remember, all students take calculus. All students take calculus. They're all positive here. Sine is positive here. Cosine and tangent are negative. Tangent's positive in the third quadrant. Sine and cosine are negative. Cosine's positive in the fourth quadrant. Sine and tangent are negative. So now, let's see what we can do with these 5 examples. I'm going to start out with 5 pi over 6, the cosine of 5 pi over 6. Now, this is one that you should have memorized, and you should know the answer right off the top of your head. But 5 pi over 6 here is in the second quadrant. It's between pi over 2 and pi. You can see that this is between pi over 2 and pi. So in the second quadrant, my relationship is pi minus theta prime. So I'm saying that pi minus theta prime to equal 5 pi over 6 means that theta prime is going to be pi over 6. Do the arithmetic there. Solve that equation. So and then in the second quadrant, remember cosine in the second quadrant is negative. So what I'm going to tell you is that the cosine of 5 pi over 6 is negative the cosine of the reference angle. And this is from earlier in the section here. The cosine of pi over 6 is the square root of 3 over 2. So this is equal to negative the square root of 3 over 2, which you should have already had memorized, as I mentioned before. So that's how you can use the reference angle and basic knowledge on pi over 6, pi over 4, pi over 3, and of course 0 and 2 pi to evaluate these trig functions. Now we'll jump over here, the cotangent of negative 120 degrees. Now, cotangent is the one that I have right off the top of my head, but I can figure this out. I am first going to deal with the fact that I have negative 120 degrees, which is not between 0 and 360, it's negative. So I'm going to find a coterminal angle for negative 120 by adding 360. this is equal, if I add 360 to this, excuse me, to the cotangent of 240 degrees. Now these are different angles, but they're coterminal and they'll have the same cotangent. They'll have the same sines, cosines, tangents, cotangents, and so on. So now I'm looking at a guy I can deal with. I am in the third quadrant, 180 degrees plus, so my reference angle here, a little scratch work, is 180 degrees plus my reference angle is going to equal 240, which means my reference angle is 60 degrees. Now in the third quadrant, tangent is positive. Cotangent's the reciprocal, so if tangent's positive, its reciprocal is positive. So I am telling you that the cotangent of negative 120 degrees, which is equal to the cotangent of 240 degrees, is equal to the cotangent of the reference angle, 60 degrees. Now, you might not have the cotangent of 60 degrees memorized, but you should have the sine and the cosine, and since the reciprocal relation, the quotient identity for cotangent, I almost said reciprocal, cotangent of 60 degrees, it would be the cosine of 60 degrees over the sine of 60 degrees, which is 1/2 divided by the square root of 3 over 2. You have to invert and multiply. I'm going to get 1 over the square root of 3, and if I rationalize by multiplying top and bottom by the square root of 3, I get the square root of 3 all over 3. Oh, if you can read that. There we go. Negative or positive, the square root of 3 all over 3. Alright, now we're over here to this guy, 7 pi over 4. Now 7 pi over 4, this would be like 1 point, if you divide 7 by 4, this would be 1.75 pi. So that is between 0 and 2 pi. In fact, that's in my fourth quadrant. Remember 0, pi over 2, pi, 3 pi over 2, 2 pi, all the way around. This is in the fourth quadrant. I don't have to find a coterminal, but I can go right after finding the reference using this relationship right here, 2 pi minus theta prime. So my reference angle, 2 pi minus theta prime equals 7 pi over 4. My pen's starting to go here a little bit. If I solve for theta prime, I get 2 pi minus 7 pi over 4. This is 8 pi over 4, so theta prime is pi over 4. Now again, I'm not saying that 7 pi over 4 is equal to pi over 4. It's clearly not. It's 7 times bigger. But they are, this is the reference angle of this, and I can use the reference angle to find, in this case, the cosecant of 7 pi over 4. Now, remember that the cosecant is the reciprocal, coming back over here, the cosecant is the reciprocal of sine. I am in the fourth quadrant. Sine is negative in the fourth quadrant. So cosecant is negative in the fourth quadrant. This C isn't for this one. This is cosine. Cosecant is negative in the fourth quadrant. So I am telling you that this is negative cosecant of my reference angle, pi over 4. Now, what's the cosecant of pi over 4? Well, it's 1 over the sine of pi over 4, which is 1 over the square root of 2 over 2. Invert and multiply. This is negative 2 over the square root of 2. Rationalize my denominator by multiplying top and bottom by the square root of 2. I get negative 2 square roots of 2 all over 2, or just negative the square root of 2. There's a lot of work there to get to the cosecant of 7 pi over 4 is negative square root of 2. 2 more to go here. I picked these last two because these angles are clearly not between 0 and 2 pi, or 0 and 360. This is 11 pi. I need to find a coterminal angle, so I'm going to start subtracting 2 pi. 11 pi minus 2 pi, 9 pi, too big. 9 pi minus 2 pi, 7 pi, too big. 7 pi minus 2 pi, 5 pi, too big. 5 pi minus 2 pi, 3 pi, still too big. 3 pi minus 2 pi is pi. I'm telling you that this is the same as the cosecant of pi. Wow, I had to drop off a lot of 2 pi's to get to that, but the cosecant of pi would be in the, well, not in the second quadrant, not in the third quadrant, it's a quadrantal angle. So this is going to get a little tricky because the idea of a reference angle really doesn't apply here because we're not in one of the 4 quadrants. We're doing a quadrantal angle. So what do we do here? Well, in this case, the cosecant of pi would be 1 over the sine of pi. because cosecant and sine are reciprocals. What's the sine of pi? Over here, 180 degrees, pi radians, you're looking at the sine of pi, the y value, being 0. So this is 1 over 0. Well, we're going to say undefined. Now, I don't like writing equals undefined. I prefer implies. This double arrow means implies that it's undefined. Let's go over to this guy for the cosine. It's negative. I'm going to start adding 360s. If I add 360 to this, now negative 600 degrees plus 360 degrees is going to give me negative 240 degrees. Well, that's still negative, so I'll add 360 again. Negative 240 degrees plus 360 degrees is going to give me 120 degrees. Now that guy I can work with. I am telling you that the cosecant of negative 600 degrees is the same as the cosecant of 120 degrees. Because these are coterminal angles. They're going to intersect a unit circle at the same point. They're going to have the same x's, the same y's, the same x's here. So 120 degrees puts me in the second quadrant. 180 minus theta prime. So 180 degrees minus theta prime, my reference angle, is going to equal 120 degrees. That means theta prime is 60 degrees. Now, I'm in the second quadrant. In the second quadrant, cosine is negative. Sine's positive, but cosine is negative. So I am telling you that the cosine of negative 600, which is the cosine of 120, is going to be negative the cosine of my reference angle, 60 degrees. Now, what's the cosine of 60 degrees? Well, it's a half. So this is a half here, so this is negative 1/2. And that's my answer. So you can use the reference angles here to help you evaluate pretty much the trig function of about any angle. Fortunately for right now, everything that we've been working with has been a multiple of 30 degrees or 45 degrees, and then we can refer to that unit circle that we should have memorized. I keep saying that, we should have that memorized to help find these values.